Hey everyone, today we're doing LeetCode problem number 1894. Find the student that will replace the chalk. This is today's LeetCode daily. And if you're liking the content you're watching, please do like, comment, and subscribe on the video. It'd be very useful to show that I'm taking a positive direction when it comes to making these videos. There are n students in a class numbered from 0 to n-1. The teacher will give each student a problem starting with the student number 0, then the student number 1, and so on until n-1. After that, the teacher will restart the process starting with student number 0 again. You're given 0 indexed integer array chalk and an integer k. There are initially k pieces of chalk. When the student number I is given a problem to solve, they will use chalk of I pieces of chalk to solve that problem. However, if the current number of chalk pieces is strictly less than chalk of I, so it has to be strictly less, then the student number I will be asked to replace the chalk. Return the index of the student that will replace chalk pieces. Okay, so let's try and break down the problem for us, figure out the caveats of the problem. We have example 1, which says, given a list 515. So these numbers are basically how much chalk used by each student, right? And in total, we have 22 chalk we can use. So student 1 is going to end up with 22. After student 1's used their chalk to solve the problem, we're going to end with 17. And then we're going to end with 17 minus 1 for student number 2. So 16, and then so on. So we have 11, and then we're back to 6, and then we have 5. We have 0. So student 3 can use 5 pieces of chalk. That's exactly what they need. And finally, we're back to student number 1. I'm kind of 1 indexing it, but it should be 0, 1, and 2. So student number 0 would have 0 piece of chalk left to use, and thus we would return the index of that student, which is 0. That makes sense. And in this case, like, even if we have 2 pieces of chalk left and there's a student that uses 3 pieces of chalk, we return that student. Right. Okay. Let's go ahead with the problem and see what we can do, how we'd logic our way through this. So what if, most obvious solution, we're starting with index 0. We'd have some kind of nested for, or we'd have like a while loop, while k is greater than chalk of I, something like that. So here we're saying if the chalk of the ith student, all k is greater than that, you technically get to subtract and keep going. But the moment we hit this statement is no longer true, we just return the ith value. Wait, on paper this sounds very straightforward, and the way we increment I is the moment I is equal to the length of the list. The moment I is equal to len of list minus 1, right? We're basically I is at the very last element. So in this case, when I is at 2, we say just reset I, make I equal to be 0 again. This logic on paper makes a lot of sense. Also, it doesn't seem like this problem should be a medium problem, but we could type up the solution and see what we run into. What concepts does it really use? I feel like this is an array type of question. List manipulation. We'll see where we go. I'm not really going to think too deeply about the solution if the solution seems straightforward. Let's set an I to be starting at 0, while k is greater than or equal to chalk of I. We know we're in the clear. The one question I have is, are we able to constantly access like new elements of chalk of I? I feel like we should be. K minus equal chalk of I. If I equals len chalk minus 1, I'm going to set I equals 0, return I. You also need to increment I otherwise, else you go I plus equals 1. I feel like there's some edge case based off how long it's running for, I feel like. So I can't use a while loop. Okay, so the time limit exceeded on a case where we use the while loop. So it's not that straightforward. Oh, but in this case, I just feel like K is absurdly higher than. Let's add a little case. If K is greater than or equal to sum of chalk, while K greater than or equal to sum of chalk. Or instead, I could just do K mod equal, right? So mod equal is basically divide it as many times as you can, whatever the reminder is. Just store that reminder, and then you start. So we know during that iteration, you're gonna find. Is that how you? Does that make sense on paper? I'll explain it when I run the solution. Sweet. Alright, the reason why that line was important is because what we're saying is, you know, if K is like an absurdly large number, and we're gonna have to take so many iterations over our over our list, chalk, it would be smarter to just take the entire sum of chalk. Like, imagine one iteration where you're going through every single element of chalk, adding that together and just subtracting it from K if we know K is like that much larger. So we're saying, okay, take the sum of chalk. How many ever times K can divide that sum of chalk? Just divide it. And whatever we're left with is our new starting point for getting into our while loop and figuring out of where it's going to stop is. So this step effectively eliminates going over and over the chalk array and jumps us straight to the step where we only have to go through it one more time, where the element will be somewhere inside. Hopefully that solution makes sense. It seems people have taken a similar approach using mod, and it seemed to be the one that made the most sense to me. But thank you guys for watching. Hopefully this was a helpful tutorial where you guys learned something. It's always fun to crack these solutions, and so I will see you guys next time. Peace.